Hello, we're going to look at the schematic for the H-bridge motor driver circuit and its breadboard layout here. There's a breadboard layout. We're going to start with power. VCC is power and ground, and power is connected to the red strip at the top here, and ground is connected to the bottom strip here. Moving down, we see the four power transistors, the N-channel MOSFETs, M1, M2, M3 and M4, and they're shown on the on the breadboard layout here and here, here and here. And we're going to start with the top two, M1 and M3, and we can see that M1 is joined to M3. I've used a red wire on the schematic to correspond with the red wire on the breadboard layout. So that middle pin for both of these transistors, that middle pin connects the drains together. The top connection is known as the drain. At the bottom, the source, the bottom connection for M2 and M4, is connected using a black wire, and that black wire is here, and that connects to ground in the same way that the drains at the top connect to power. In the middle, we have a purple wire which joins at this point on both sides, and the purple wire connects the source of M1 to the drain of M2, and the source of M3 to the drain of M4. And it's at this point here, this track, that's where you're going to connect your motor. You're going to connect your motor this side, and you're going to connect your motor this side, here and here. We'll also notice that there are two diodes either side. That's this diode here and here, here and here, and those are protection diodes to protect the motor. The motor's an inductive load. Switching it causes the potential for massive voltage spikes, very temporary massive voltage spikes, which can destroy your transistor. That's why these diodes are very necessary, and they need to be in your circuit. In operation, we will look at J1 for example. So when I switch J1, J1 connects a voltage to the gate of M1 and M4. We'll notice that all four transistors are grounded. The gate is grounded through a large value resistor. I've used 4.7 megohms here, and just to show you on the breadboard plan, that for example would be this gate here would be grounded, but we'll notice that all four gates are grounded. So we switch on J1, we have a switch on voltage for M1 and we have a switch on voltage for M4. That causes M1 and M4 to conduct. Current flows through them, through the motor, and causes the motor to spin in one direction, for example clockwise. In the opposite configuration, if I switch on J2, M3 and M2 will conduct, and this time the motor will spin in the opposite direction because we've got an opposite direction of current. You do need to arrange, or at least make sure, that there is never a situation where you can switch on J1 and J2 at the same time, because if you do that you'll get a short circuit through M1 for example, down through M2 to ground, massive current flow, and the potential to destroy your transistors. That's about it. Hopefully it's nice and clear. I have tried to color code everything so it's a little bit easier to follow than just a normal schematic, and show you how it works on the breadboard, and I hope you get on well with it. Okay, bye. Okay, this is the H-bridge circuit that we're looking at here. These are the four power MOSFETs. Ignore this is another circuit I've been working on. So, four power MOSFETs. Here's the switches. It's going to be difficult for you to see exactly how everything's arranged. That's why I've done a breadboard plan. Powered from a 9-volt supply here. Here is the fan. So when I switch, you can see the fan goes in one direction. And when I switch the other switch, fan goes in the other direction. And we notice that the motor is connected here and here, so you're going to connect the motor one on one side, one on the other side. That's pretty much all there is to it. If you just follow the plan I've provided, it will work just fine. Thank you.